This tutorial forms part 2 of the Com.X commissioning tutorial and proceeds from the configuration detailed in the first part. In order to place a call, there needs to be a trunk to some telco provider, be it SIP or traditional, and moving from the extensions panel to the trunks panel, we show existing trunk ports for the devices that are configured. These ports can be grouped together by simply control-clicking them and creating a new group. Groups have to have ports of the same type. Pry ports are automatically grouped into the P group, but Bry ports have to be grouped as shown. Once grouped, if you move to the port on the hardware panel, you can see now that the detect fax and echo cancellation options for Bry ports have become available. Those settings apply to the entire group and all the ports inside it. There are the Pry channels automatically grouped and the analog group that we created. You can also easily add SIP or iTAs provider settings here. The trunk can be created either as providing, as registering with the provider, and can be forced to use a username and the from user fields by configuring these fields and checkboxes. Please ensure that the codec configured on the trunk matches up with the provider's codec. Adding an iTAs provider is as easy. Qualify connection on SIP and iTAs trunks periodically polls the connection to ensure that connectivity is up and that the registration is still active. Here is an example of providing an iTAs service to a registration client. This is the provider side of the trunk. To check whether SIP and iTAs trunks are up, first see whether the peers are visible. You can see there that no phones are registered with those extensions, but the trunk is up, and the milliseconds displayed in brackets there is a delay on the link between the trunk partners, trunk peers, including the processing stack inside each device. The time it takes to process the SIP messages and the responses. You can see that the SIP trunk's been registered, and that's success. Looking at outbound routing, outbound routes consist of dial patterns which match when a call is tried on an outbound trunk, and trunks to which the call is routed. Trunks can be prioritized by simply placing them in the correct order in the trunks list here, and calls automatically fail over from one trunk to the next should a trunk be unavailable. You can add as many trunks as you like in the trunks priorities list here. To reprioritize a trunk, simply right-click and move it to the right position. Dial patterns uses a complex dial pattern string, including number ranges and wildcards. You can also create a pin on an outbound route, and we certainly recommend this for international or high-cost routes. Adding a test pry trunk here to carry pry calls over the pry link between the test PBX and the one that we're setting up here. The dial pattern there is an 8-8 pipe X dot. That means that 8-8 is stripped from the front of the number dialed and the remaining digits are dialed across the trunk. You can easily look at the current configuration for your outbound trunks by simply selecting each one here. The details are displayed at the bottom. In order to process calls, we need to set up inbound routing. Inbound routing also selects a specific destination based on the configuration provided for a dial pattern. When the DID or CID matches on the incoming call, the specific destination is activated. Any destination in the system can be used in an inbound route. In this case, we are explicitly matching DID 3000 and passing the call through to music on hold service. Leaving DID and CID empty as in the first inbound route there matches all calls. It is important to realize that for inbound routes, the more specific match is selected if there are multiple possible matches for the same incoming DID. So how do we monitor the system and see that our calls are proceeding properly? Well, let's log on to the shell console for the system using PuTTY here and log on to the PBX console. From here we can see real-time call traces as calls progress, and we can also see extensions going off hook and on hook. We can see services being played out and routing taking place in real time. There we see the prior channel isn't quite up yet, so let's plug in the cable. Warnings and error messages are also displayed in this console and are useful to detect wiring problems, ports going down and up, and so forth. There we go, the prior channel's up. And the channels are available to place calls. Simple switch is an indication that an extension has gone off hook, and there it goes on hook again, off hook. There's a call proceeding across a trunk. We can see which trunk's being used by looking at the traces, and we can also see the remote side's feedback. In this case, the SIP trunk replied with a 603 declined. The dial pattern we used was not matched by the remote SIP provider. There is a call dialing out over group 1. That's a pry link. And we can see the call proceeding, speech is active. The call has been terminated. There's an incoming call from a remote system, and we can see it's got DID 3000, which matches our inbound route and terminates in music on hold. We can see here the call inbound went through to the extension and activated follow me. And there's an inbound call that's routing to an extension, and you can see the extension ringing.